NFS has been around since the 80s and has gone through several revisions. The popular NFS versions that are in use today and that come standard with Linux distributions are NFS version 3 and version 4. There is one fundamental difference between these two versions, and that is that according to the protocol specification, NFS version 3 is stateless, whereas NFS version 4 is stateful. The fact that NFS version 4 is stateful allows it by design to support operations like client caching and file locking. And although NFS version 3 is stateless, actual implementation of this protocol typically incorporate additional modules so that file caching and locking can be supported. The caching semantics in NFS are as follows. For files that are not accessed concurrently, NFS behaves with session semantics. On close, the changes are flushed to disk. For files that are not accessed concurrently, NFS behaves with session semantics. On close, all of the changes made to a file are flushed to the remote server, and then on open, a check is performed, and if necessary, the cache parts of the file are actually updated, so the new versions of those files are brought in. However, as an additional optimization, NFS also supports periodic updates. These are used to make sure that there aren't any changes on the file that the client is working with, and using these periodic updates will break the session semantics when there are multiple clients that are concurrently updating a file. The periods on when these checks happen can be configured, but by default, NFS uses these values. It uses 3-second checks for the regular files, and at 30-second intervals, it checks whether there are any changes with the directories. The rationale behind these numbers is that the directories as files are modified less frequently, and that when modified, it is easier to merge those changes. So we don't have to check for changes in the directories as frequently as we have to check for changes in the regular files and still have a consistent system. NFS version 4 further incorporates a delegation mechanism where the server delegates to the client all rights to manage a file for a period of time. And this will avoid any of the update checks that we described here. With server-side state, NFS can support locking. The way NFS supports locking is using a lease-based mechanism. When a client acquires a lock, the server assigns it a particular time period during which the lock is valid. It is then the client's responsibility to make sure that it either releases the lock within the leased amount of time or that explicitly extends the lock duration. This helps deal with situations of client failure. So in this case, when a client fails, on the server side, we'll just realize that, okay, the lease for this client expired, so we can assign the lock to somebody else. And then when the client comes back again, or when network connectivity is reestablished, the client will know that the lease expired, it no longer has a valid lock, so whatever changes it was trying to make, it simply has to redo. They weren't applied in an exclusive manner. NFS version 4 also supports more sophisticated mechanisms than just a basic lock. For instance, it supports a reader-writer lock called share reservation, along with mechanisms on how one can upgrade from being a reader to being a writer for a file and vice versa.